On a warm August night in 1977, a radio telescope in an Ohio field was doing what it did every night, listening to the sky. No one was even in the room. The data just printed out, line after line, onto paper. A few days later, an astronomer named Jerry Amon sat down to review the printout and froze. There, in one narrow column, was a signal 72 seconds long and roughly 30 times louder than the background hiss of deep space. He circled it in red ink and wrote one word in the margin: wow. Signal came from the direction of Sagittarius, toward the crowded heart of our galaxy, and it arrived at 1420 MHz, the natural broadcast frequency of hydrogen, the most common atom in the universe. Scientists had long predicted that any civilization wanting to be found would transmit exactly there, the one channel every radio astronomer in the galaxy would be watching. The wow signal wasn't just loud, in other words, it was on the right station. It looked like the phone ringing. Astronomers have pointed telescopes at that patch of sky for nearly 50 years since. Satellites, comets, reflections, glitches, every ordinary explanation has been proposed, and everyone has problems. And in half a century, the signal has never repeated, not once. Every explanation has been thrown at it. Satellites, wrong band, that frequency is protected, nothing is allowed to transmit there. A passing comet proposed in 2017 and dismantled within months when astronomers showed it wasn't even in the beam. Interference, the telescope had two receiver horns, and a real earthly signal should have appeared in both. It appeared in one. And here's the ending that stings. The Big Ear telescope was demolished in 1998. The land was sold to expand a golf course. The instrument that may have caught humanity's only incoming call is now buried under a fairway. 72 seconds, one night in 1977. That is mystery number one, and it is only the beginning. Mystery number two announced itself in 2007, buried in old telescope data from Australia, a flash of radio energy that lasted 5 milliseconds. Blink and you'd miss it, except in that blink, it released roughly as much energy as the sun puts out in days. They are called fast radio bursts. They come from other galaxies billions of light years away, and they are everywhere, invisible to your eyes, thousands of them raining down on Earth every day. The first one was found in 2007 by a student combing through years-old archived data from an Australian telescope. The most powerful radio events in the universe had been sitting on a hard drive, unnoticed, for 6 years, and for a while, many astronomers refused to believe the discovery was real. In 2020, astronomers caught a break. One of these bursts fired from inside our own galaxy, and the culprit was a magnetar, the corpse of a giant star with a magnetic field 1 trillion times stronger than Earth's, so extreme its crust cracks and quakes with energy. Then a Canadian telescope called CHIME switched on and started catching them by the thousands, and the collection got weirder. Some bursts repeat, one on a clockwork cycle of roughly 160 days, like a lighthouse. Others fire once and vanish forever. One was traced to a galaxy so ancient and dead that it shouldn't contain young magnetars at all. Magnetars may explain many of them. Nobody can prove they explain all of them. Something out there is flashing, and we still don't fully know what. Mystery number 3 flew past us, and we only saw it on the way out. In October 2017, a telescope in Hawaii caught something moving impossibly fast across the sky. When astronomers traced its path, they realized it wasn't from here. It was the first visitor from another star system ever detected. They named it Oumuamua, a Hawaiian word meaning, roughly, a messenger from afar arriving first. It was moving at 87 kilometers per second, far too fast to belong to our sun. It had been falling between the stars for millions of years before threading our solar system at the exact moment we were finally able to notice. And it was strange, shaped like nothing we'd ever seen in space, possibly 10 times longer than it was wide, like a cosmic cigar, tumbling end over end every 8 hours, its surface reddened by eons of cosmic radiation. Then it got stranger. As it left, it accelerated, something pushed it gently away from the sun. Comets do that, propelled by jets of evaporating ice, but no one could see a tail, no jets, no dust, nothing. A Harvard astronomer made headlines by suggesting we should at least consider an artificial origin, a piece of alien technology, a discarded light sail. Most scientists favor natural explanations, a shard of frozen hydrogen, a fluffy fragment of a shattered comet venting gas we simply couldn't detect. But here is the honest truth: it was moving too fast for anything to chase it, and it is gone forever. The first confirmed interstellar visitor in human history came and went in weeks, and we never got a good look at it. 2 years later, a second interstellar visitor arrived, a comet called Borisov, and Borisov was completely, boringly normal. Tail, gas, ice, everything by the book, which somehow made the first one worse. The normal one proved we know exactly what interstellar visitors should look like. Oumuamua didn't look like that. A new observatory in Chile is now sweeping the entire southern sky every few nights, and it's expected to catch interstellar objects routinely. The next Oumuamua is already on its way, and this time space agencies have sketched plans to chase one down. Mystery number 4 is a star that flickers wrong. In 2015, citizen scientists combing through data noticed a star 1,400 light-years away doing something no star should, dropping in brightness by up to 22% at random with no pattern. A planet the size of Jupiter blocks about 1% of a star like this. Whatever was passing in front of Tabby's star was blocking 20 times that, and it kept changing shape. One published paper dared to say the quiet part out loud. The dimming was consistent with a swarm of enormous artificial structures, the kind of civilization might build to harvest a star's energy. For one wild year, the world's telescopes swung toward it. Astronomers even dug through a century of archived photographic plates and found the star has also been slowly, steadily fading for 100 years on top of its random deep dips. No known star does that either. The evidence now points somewhere less dramatic but still unexplained. Colossal clouds of fine dust, maybe a shredded moon or a swarm of disintegrating comets, orbiting in a configuration seen nowhere else in the galaxy. The alien megastructure faded from the headlines. The star is still doing it. Mystery number 5 is the biggest one of all because it isn't one strange signal or one strange star. It's everything. Watch any spiral galaxy rotate and the stars at its edge are moving far too fast. By every law of gravity we know, these galaxies should fly apart. They don't. Something invisible holds them together, something that outweighs everything we can see about 5 to 1. We've watched galaxy clusters collide and seen the invisible mass sail cleanly through the wreckage, bending light as it goes. We can map it, we can weigh it, we cannot find it. We call it dark matter. An astronomer named Fritz Zwicky saw its fingerprints back in 1933 and was ignored for 40 years. Then Vera Rubin measured those impossible galaxy rotations in the 70s, and the fingerprints became a case file. Ever since, physics has been hunting the culprit. Stakeouts are extraordinary. A kilometer underground in caverns shielded from every stray cosmic ray, tanks of liquid xenon sit in silence, watched by the most sensitive light sensors ever built, waiting for one dark matter particle to bump one atom once. Detector after detector, decade after decade, bigger and bigger. Not one confirmed bump ever. And in 1998, it got worse. Astronomers measuring distant exploding stars discovered the universe's expansion is accelerating, as if some repulsive energy is woven into empty space itself, pushing everything apart harder every year. They call it dark energy. The discovery of dark energy is its own detective story. In 1998, two rival teams raced to measure how much the universe's expansion was slowing down, each hoping to beat the other to the answer. Both found the same impossible thing. It isn't slowing down at all, it's speeding up. They shared the Nobel Prize for ruining cosmology. Added up in the scoreboard is humbling. Dark energy about 68% of the universe, dark matter about 27%. Everything you have ever seen, every star, every galaxy, every atom in your body is about 5%. We are the rounding error. 5 mysteries, a signal that rang once and went silent, flashes that outshine galaxies, a visitor that accelerated away into the dark, a star wrapped in something we can't name, and a universe that is 95% missing. Here's the thing about that list. A century ago, we didn't know other galaxies existed. Every mystery on it was invisible to us. The universe isn't running out of secrets, we're just finally close enough to hear the questions. Next time there's a galaxy in your night sky, visible to your naked eye, the most distant thing a human can see without a telescope, it is 2.5 million light-years away, and it is coming toward us at 400,000 kilometers per hour. For a century, scientists said the collision was inevitable, our galaxy's death written in the stars. Then, last year, they reran the numbers. What they found changes everything you've been told about how our galaxy dies. That's next.